Okay. Well, it says I'm recording, so we'll see how this goes. Okay. So let's cover the essentials here. So let me flip into Paint. We'll do the share. Life will be good. Okay, we're going to share with Paint. Okay. So hopefully everyone can see Paint. That's good if you can. So unlike previous versions of this course, okay, number one, no quizzes or exams. And number two, extra programming assignments. Okay, that's the trade-off we have here because we're living in the age of remote learning, apparently. And there's not much point giving a quiz that people can easily look up the answers to, or likewise giving an exam that is typically about fairly simple syntax or programming issues that, again, people can look up the answers to, right? I don't have a problem with open book exams, but it's just kind of silly in Java. So anyway, so that's the way we're going to do this. I'm not gonna fight that uphill battle. Instead, I'll give you a little bit of extra programming assignments. In particular, lab exercises that used to be solely for practice will now be turned in and graded. But they'll be graded gently, right? The lab exercises are still more for practice. And there's an extra big-ish programming assignment. Okay, so that's the trade-off. The workload, I hope, is about the same, but that is what it is. Okay, the second thing we want to talk about today, this is really all I'm going to go over is why we're doing the course, why we're learning Java. Okay, so this course is entirely about programming in Java. Okay, so you might ask, why should we learn this language? Well, number one, it's arguably the most widely used business programming language. Okay, and the reason for that is, unlike a lot of languages, Java is what's called platform independent. A program written in Java can potentially run on any machine, whereas a program written in some other language like, say, C or C++ is typically for a particular hardware configuration. So you need to write a specific version of it for each different type of hardware you're doing. So for business programming, they want to have the same program run on a bunch of different servers and not have to worry too much about tweaking it for each individual one. Something like Java is great and is widely used for that. The other thing, because it's pervasive, right, because it's the most widely used programming language, there will always be a need for people to tweak existing programs. Okay, so even if you're not writing the stuff from scratch, businesses have lots and lots of Java code in their systems, and they need people to maintain it. They need people to make slight changes here and there. Yeah, so when some new language comes along, right, typically a business is not going to rip out its entire system by the roots. Instead, it's going to say, well, does our existing stuff written in Java work well enough? If so, then they're just going to upgrade it. And so they'll need people for that. I will add this. In practice, right, typical programmers know Java plus one or more. Okay, so basically everybody who's out there who considers themselves a programmer, or a serious one who's not doing just simple stuff like web design, is going to know Java, right? I'll say maybe Java or C++ or something like that, plus a few others. Okay, so Java, even if you end up never using it, it is a great base. Java is a great base for other simpler languages, right? For example, in IDS 3.13, I have a chunk of the the course where I teach JavaScript. In some ways, JavaScript is like a greatly simplified version of Java. So once you've learned Java, if you survive IDS 201, then you might take something like IDS 313 and learn JavaScript, or IDS 400 and learn Python, and you'll be like, wow, these languages are so easy. Okay, so once you've learned Java, you know, everything else, except maybe assembly code that you only get if you're a hardcore computer science person, everything else is relatively easy. Okay, and the logic of the department, right? So the logic of the department is that every IDS major should at least experience a serious programming language. And Java is one of those. Okay, so that's the idea. If you don't like it, that's okay. At least you know you tried it and didn't like it. Okay? But if you like it, that's great. You know, then coding could be a substantial part of your future career. And if you do like it, well, that's wonderful. Okay, so that's Java. That's the quick interest. It's out there. It's widely used. People are hiring for it. I have had people go on and get Java internships and other positions where programming in Java was a substantial part of their work. This is a useful thing. Okay, good. We're all happy? We're happy enough? Okay, I'm going to pause the share for a second. We'll check the chat. Ooh, I have some more. There's something going on in the more window. I'm not sure what. Let's see. I'm going to check the chat. Okay, so somebody asked her here, is Java plus Python a good combination? Yes. Java plus almost anything is a good combination. Okay, but I will add, we can talk about programming languages for a minute. So I'm going to bump this back to Paint. Okay, so here we are back in Paint, and I'm going to clear all that. And it should be okay because it should be still recording. If you want to look at it in a greatly simplified point of view, which we'll do now, there are two kinds of programming languages. Okay, number one, languages close to the machine itself. Okay, and in that, I would put things like assembly code, true machine language, which nobody really codes in anymore, C or C++, and Java, right? Now, if you ask computer science people, they're going to tell you Java is not a low-level language, it's a high-level language, which means it's far away from the computer. And that's true. But compared to what we're doing here, yeah, Java is pretty close. You don't have as much flexibility. So Java is closer to the machine than these other languages I'm going to tell you about. Others, languages far from the machine, close to the users, right? So languages like Python or JavaScript or heck, HTML or SQL, right? Structured query languages for databases. Things like that, you don't need to know any of the details of your machine, and there's a lot of freedom in how you write the code. As we'll see, in Java doesn't give you quite so much. Okay, so if you take one of these, then you can say, for serious programmers, right? And if you take one of these, you can say, maybe it's not for super serious programmers, but you know, you can say this is immediately useful and can be done on a variety of systems and platforms. Okay, so that's the idea. Group one here, those are serious languages. They have a lot of what's called data typing involved, where you have to put specific variables or data types. You have to handle them in certain ways. Those are considered like serious programming languages. Once you learn one of those, and like if you learn Java or C++ or C, it's pretty easy to pick up the other ones if you need to. Assembly code is a whole different beast, but if you have the wherewithal to learn assembly code, you will not have too much trouble with any of the others. Okay. These ones in group two, Python, JavaScript, HTML, SQL, they're all certainly useful, widely used programming languages, but they're different. They don't impose quite as much structure. And so if you know one of them, for example, if you know Python or JavaScript, it's like a light version of Java. If you know HTML for writing web pages, sure, that's useful. If you know SQL for writing queries, sure, that's useful. That's something, right? So anyway, these tend to conform to immediate particular job roles, right? If you're a database person, you say, oh, I'm proficient in SQL. Good, you get a job doing database stuff. If you're proficient in HTML, you can write web pages. JavaScript, you can do web apps. Python, you can do data analysis, data analytics programs. Okay, so these are generally languages with a very particular target, right? And these ones up at the top, they're more general purpose for well, they're like for building platforms, if that makes sense. I hope it does. Okay, so that's the nature of Java, but I would like to take a moment to talk about why Java is the way it is. So we're gonna, if I can, I wish this thing would go away. There we go. Okay, so I want to switch color back to black. Okay, so remember I have said Java is platform independent, but C++, which is very similar to Java otherwise, but C++ is not. So let me give you an example. Suppose you have a particular hardware configuration, right? We'll say you have some PC machine, okay? Not a Mac, you got a PC. If you write a program in C++, okay, first of all, we're going to talk about source code. So the source code is the language that the humans write. Okay, so when I talk about writing a program in C++, I as a human am going to use C++ syntax. But the computer doesn't read that. The computer will compile it into compiled code, right, or object code if you like. That runs directly on the machine. Okay, so I write something in C++, for example, I call some method like g.draw line 0, 0, 100, 100, right? Suppose I call some function that's going to draw a line on the screen. In C++, that line, that little code statement there, is going to be compiled to particular graphics addresses on that particular machine configuration. Okay, so if I want to change that, right, so once I write the code and compile it, if I change anything in the hardware configuration, that code is no longer going to run. I'm going to have to recompile it. Okay. Another issue with C++, the programmer is generally responsible for memory management. Okay. If I want to reserve a block of memory that my program will use, I have to say so, right? I have to specifically say these variables are assigned to these particular memory addresses, right? I have to reserve that block of memory within my program itself. Okay, all that means, okay, so I go through some compilation layer. Okay, so source code, and over here, compiled code. Okay, this will run. But again, once the code is compiled, it's only going to run on that particular thing. So I would have to recompile it all again, right? And again, because in C++, oh, hey, we got a new person. Because in C++, I'm responsible for memory management. If I make a substantial change in how the computer is set up, for example, it has more or less memory, some of those memory addresses may not be available for whatever reason, then I'm going to have to really dig in there and retool my entire program. Okay? That's what happens with C++, which is not platform independent. Java, on the other hand, let's do Java over here. So suppose I have a box. This represents a Java program. Okay. In Java, there is a wonderful little tool called the JVM, the Java Virtual Machine. Okay. Java Virtual Machine, what it does is a program that abstracts the current hardware configuration. So, for example, I'm trying to move this thing. Let's see if I can grab it where I need to. Things never move easily when you want them to. Let's move it there. Fine. Okay. So, if I write a program in Java, it automatically runs through the JVM, right, through the Java Virtual Machine. That means that even though I compile it, it runs through the Java Virtual Machine. So what does that mean? Well, if I start off with some PC, okay, and I do some similar statement in Java, like draw a line on the screen, Java will send a method. All right, my program that I've written will send a message to the Java Virtual Machine saying, you know, draw a line 0, 0, 100, 100. I'll draw that line. The Java Virtual Machine automatically knows what memory addresses that corresponds to, because all the hardware specs have already been sent to the Java Virtual Machine. So the Java Virtual Machine knows what memory addresses the graphics area, you know, the screen resides at. So even though I compile it for the Java Virtual Machine, not for the particular hardware it's going to run on. Okay? That's kind of a neat thing. The other thing I'll add, Java automatically handles memory management with a tool that's called garbage collection. Basically, initially you allot a certain amount of space to run your program in called the heap. And over time, Java says, oh, here's some variables, some data you're not using anymore. We're going to free up that memory for other uses. Okay, so in C++, you have to specifically reserve memory when and where you want to use it. In Java, you don't have to. It automatically manages that for you. So this simplifies a lot of issues. Okay, so I'm going to draw a line down the middle. So languages like C, C++, they are not platform independent. They're designed for a particular hardware configuration. Languages like Java, because there are some other ones like this, are platform independent. When you write the code, it gets compiled, but it runs through a Java virtual machine that the PC, the computer you're running on, already has translated its hardware specs into that. So when you send the instruction to the Java virtual machine, draw a line, it can do that for whatever machine it's installed on. So the same Java program could draw that line on a Mac or on a PC or a Linux machine, whatever. Okay? I hope that makes sense. All right, so that's the magic of Java. That's why Java is useful and important and all that. So I'm going to stop the share for a moment. And I'm going to pause the recording. I'm going to stop the recording for now.